Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends. In this video we are going to study about the features of an ARM processor. First we will study that what is an ARM processor, and then we will see some of the features of the ARM processor. So let us start with our topic. So let us first understand that what is an ARM processor. An ARM processor is one of the family of CPU which is based on the RISC architecture. The CPU present in the computers, it is based on two types of architecture. The CPU can have two types of architecture, RISC architecture and CISC architecture. The full form of RISC is Reduced Instruction Set Computer. And the full form of CISC is Complex Instruction Set Computer. In the RISC architecture, the number of instructions involved is less. And the instructions are also very simple instructions. Whereas in the complex instruction set computers, there are more number of instructions, and these instructions are also very complex. Okay, so the ARM processor, they are the family of CPUs which uses the RISC architecture. Okay, so we can define the ARM processor as is one of a family of CPUs based on the RISC architecture. Now this ARM processor, it is developed by Advanced RISC Machine. This corporation was first of all called the Econ RISC Machines, okay, and after that it was renamed as the Advanced RISC Machine. So A is for the advanced, R is for the RISC, and M is for the machine. That is why it is called the ARM processor. Okay, so this ARM processor is developed by the Advanced RISC Machine and it is based on the RISC architecture. Now this Advanced RISC Machine, it is a company, and this company develops 32-bit and 64-bit okay. So the processors which are doing the processing in the computers, okay, so they develop the multi-core processors which are using the 32-bit or 64-bit of data, okay, and based on the RISC architecture. So this ARM company, it makes 32-bit and 64 RISC multi-core processors. These processors are designed to perform a small number of instructions. As I have said, that RISC full form is Reduced Instruction Set Computer. So these RISC processors They have smaller computer instructions. And if in the computer the instructions are small, so they will be executed. When these instructions, small instructions will be executed, then it will require very less time. So small computer instructions provide high speed to the processors. And due to the high speed, they can perform millions of instructions per second. Okay, so that is a characteristic of the RISC processors, that due to the presence of smaller computer instructions, they take very less time to execute these instructions. Their speed is very high, and because their speed is very high, so they can execute millions of instructions per second, which is also called MIPS. Okay. Now, if we talk about the applications of the ARM processor, then these processors are extensively used in consumer electronic devices. Okay, an example of these consumer electronic devices are smartphones, tablets, multimedia players, and other mobile devices such as wearables. So smartphones, tablets, multimedia players, etc., the mobile devices, they are the examples of the ARM processors. Now, due to the reduced instructions, okay, because they are based on the RISC architecture, so the number of instructions will be less. So due to the less number of instructions, they will require less transistors. Okay, less instructions, it means they are having smaller instruction set. Instruction set includes all the instruction of the processor. So if there are less number of instructions, then the instruction set will be small, and due to the smaller instruction set, they will require less number of transistors. And as there are less number of transistors, so the size of the IC is also reduced. Okay, so that also provides the ARM processor one feature, which is the less size or reduced size of the processors. So these ARM processors, they not only have the high speed, but they are also very small in their size. So one feature was high speed, another feature was a smaller size. Now as the size is small, the power consumption will be less. Okay, so small size means less number of components, so less power consumption. Also, if the instructions are less, so their complexity is also reduced. So smaller size, less power consumption, reduced complexity and high speed. These are the features of the ARM processor. Now these features, they make the ARM processor suitable for miniature devices. Means those devices which are very small in size. Okay, because nowadays we see that the mobile phone size is also decreasing, and also the because smaller and smaller in size mobile phones, they can do great applications. Okay, also the smartphones, the tablets, all the sizes are reducing. Okay, so if we want to use because of the smaller size in the ARM processor, and this small size is providing us a very high speed, so that feature makes the ARM processor suitable for the increasingly miniature devices. So that is an application of the ARM processor. So these were some basic features of the ARM processor. Now let us see some of the main features of the ARM processor which are being inherited by it by the RISC processors. Okay. The first feature is the load store architecture. Okay, the ARM processors, just like the RISC processors, they also have the feature of having the load store architecture. By the load store architecture, we mean that the ALU instructions, ALU means that the arithmetic and the logical instructions in the processor, they are not going to access the memory. Okay, so ALU instructions cannot access memory. So with the memory we cannot we cannot do the arithmetic and logical instructions and operations like addition, subtraction, logical and, logical or. All these operations cannot be performed on the memory. If we want to perform these instructions, then they can operate only on registers. So registers are present in the processor. So on those registers only the ALU instructions can be operated. Now, if we want any data transfer, because suppose the data on which we want to perform the ALU instructions, if that data is present in the memory, so we have to transfer that data from memory into the registers, then only the ALU operations can be performed. So the data transfer between memory and the processor is possible only by the load and the store instructions. That is why this type of architecture is called load and store architecture, because in this architecture ALU instructions, they cannot access the memory, they can operate only on the registers. So if we want to get a data transferred from the memory into the registers of the processor, then we have to use the load and store instructions. Now load instruction, what the load instruction does, it loads the data from the memory into the processor. And in the processor we are having the registers, so the data will be loaded into the register. So if we want to move a data from memory to processor, we will use the load instruction. Now after the data has been come into the register, we can perform the ALU instructions. Now after the ALU instructions are being performed, there will be some result. Okay, so that result, if we want to store that result in again into the memory, then we will use the store instruction. This instruction stores the data in memory from the processor. So in this way, the memory can be accessed. We cannot directly access the memory. We have to first shift the data from memory into the register, and the result is then shifted from the register into the memory. So load and store instructions are used, and with the help of these instructions, we can perform the arithmetic and logical operations. Okay, so that is the first and the main feature of the ARM processors. Second feature is fixed length 32-bit instruction. So the instructions in the ARM processor, the length of those instructions is 32-bit. Okay. All the instructions are 32-bit in length. Now this fixed length, because we have said that it is the fixed length 32-bit instructions. So this fixed length, it makes the compiler, or it makes the design of the control unit simpler. Because the control unit is knowing that the length, every instruction will be of length 32-bit. So this length is being fixed. Now if length is fixed, so the control unit design will be simpler. Okay. Also this fixed length, it is going to make the hardwired control unit. This fixed length, it makes it possible to use the hardwired control unit, and this makes the control unit faster. So both the design of the control unit becomes simpler and also it becomes faster in its operation. Next feature is 3 address instruction formats. 3 address instruction format, it is also known as the 3 operand instruction format. Whenever we write the instructions in the ARM processor, so those instructions will consist of 3 operands. Okay, operands are those on which the operation is to be performed. On whatever data we have to perform the operation, that will be called the operand. So in the ARM processor instructions, we will have 3 operands. So it is also called the 3 operand instructions. Out of these 3 operands, the 2 operands are the source operand and one is the destination operand. Let's take an example. We are having the add instruction. For add, we will write ADD. So here add, then D, and then S1, S2. So S1, S2 are the source operands and D is the destination operand. So what this instruction is going to do, it is going to add the 2 sources, that is S1 plus S2, and the result of this addition will be stored at the destination. Okay, so this above instruction, that is addition, it will add the S1 and S2 and store the result in the destination. So all the instructions in the in this ARM processor, they are the 3 operands instructions. There will be 3 operands, 2 source operands and 1 destination operand. So if we write the instruction format means the pattern in which the instruction is written. So it will be first the function to be performed, like in the above example addition is to be performed, then operand 1 address is there, then operand 2 address is there, and then the destination address. So that is why it is called the 3 address instruction format. Okay, function that like addition, subtraction, whatever operation it has to perform, then addresses of the two operands, and then address of the destination. Now another feature of the ARM processor is the simplicity. Now since the ARM processor, its hardware is simple, also it has a strong instruction set. So due to these two features, it makes the ARM processor having a better code density as compared to the other RISC processor. The ARM processors, they have the better code density because the hardware is simple and they have a very strong instruction set. Okay. So these are some of the features of the ARM processor. We have seen, first of all, we have seen that what is an ARM processor. It is one of a family of CPU which is based on the RISC architecture. Then we saw some features, basic features like they have very high speed, they have very small instructions present in them, their complexity is reduced and sizes is small, they have low power consumption. After that we saw some of the features which are common in the RISC and the ARM processors. Like first was the load and store architecture, then the fixed length of 32-bit instructions, then the 3 address instruction format, and in the last, simplicity. So in this video we studied the features of ARM processor, and I hope that this topic is now clear to you. Thank you.